Okay, so let's work a little bit backward here. Um, in an earlier lesson, we talked about these things called z-scores. Okay, so let's work a little bit backward here. In an earlier lesson, we talked about these things called z-scores. And remember that if you know the mean of a population and its standard deviation, then we know that given some value x, which is a measurement on that population, that corresponds to a z-score, which is x minus the mean over the standard deviation. So we're kind of reawakening this thinking here. So the question now is, like, what if I have a population whose mean is, let's say, 100 and its standard deviation is 15, something like the IQ test, and I want the z-score that corresponds to, let's say, 80. Okay, so I would take 80 minus 100 over 15. That's 20 over 15, negative 20 over 15, which is negative 4/3, right? So it's like 1 1/3. So that means that the value for 80 lands 1 1/3 standard deviations to the left of the mean. Okay, so this is kind of useful. Okay, so this is useful because if my original population is bell-shaped and symmetric, there's a good chance that it has a normal curve. And the z-scores that are generated by that initial distribution are also going to be bell-shaped and symmetric, but they're going to have a mean of 0 and a standard deviation of 1, because the mean is now at 0 because the distance from the mean is 0, and then each standard deviation away means that my curve is now distributed with a mean of 0 and a standard deviation of 1, which means that z-scores follow the standard normal distribution. So we can ask kind of a meaty question here. So let's say that we do have a population who, when measured, has a mean of 100 and a standard deviation of 15, like IQ scores. And we want to know what percent of the population would measure between 80 and 90. Now, this is not something that I could attain by the empirical rule. If I had the empirical rule, like, I would be able to say, like, there's 68% or 95% given within one standard deviation or two, but this is not those numbers. So what we do is we find the z-score for 80, which is what we just did. We took 80 minus 100, divided that by the standard deviation 15, which was negative 20 over 15, which is negative 4/3. And then we find the z-score for 90, which is 90 minus 100 over the standard deviation 15, which is negative 10 over 15, which comes out as negative 2/3. So this means that if I find the standard normal, the percentage of the standard normal distribution that are between negative 4/3 and negative 2/3, I will know what percent of the population is between 80 and 90. So I'm going to bring up my calculator and actually do that calculation. Okay, so I want the standard normal, the percentage of the standard normal curve that is between negative 4/3 and 2/3. So just like in the last set of notes, I go second vars, and I bring up the normal CDF. I want to go between negative 4/3 and negative 2/3. And because I'm still standard normal, I'm going to keep the mean at 0, the standard deviation at 1. And I'm going to paste this. And it's going to tell me that 16.1% of the population has a z-score between -4/3 and -2/3, which means that 16.1% of the population would be measuring between 80 and 90 on my original measure, which had a mean of 100 and a standard deviation of 15. Now, this feels like a lot of work, and it really is. So the calculator actually makes this easier on me. And I can just use second vars, the normal CDF, and I can put in the two values that I want the percentage between, 80 and 90. But now it gives me an option down here to put in my mean and standard deviation. So I'm going to move off the standard normal of 0 and 1 and make my mean what the population mean actually is, which is 100. And the population standard deviation is 15. And I go and I paste that in, and lo and behold, it also gives me the same value of 16.1%. So that's a much more direct pathway. So though in reality I am converting from a normal distribution to a standard normal distribution to get the answer, if I just put the correct population mean and standard deviation into the calculator, it will do that conversion for me and get me the correct answer. So given two values, and the mean and the population standard deviation, I can return the percentage of the population that I would expect to be between those two values, provided that that measurement on the population is bell-shaped and symmetric, which most measurements that we take are because of our tendency towards centrality. All right, so there you go.